All right, so here we're dealing with the function x squared again, and a transformation of x squared. All right, this is a you can see the square function here, right? This whole thing in parentheses is squared, 2x minus 6, and then we're subtracting 1 from it. So this is actually a transformation of x squared. All right, but now we want to write g of x in the form like this, all right? In the form that we have up here that we just went over in the last video. Okay, so we're going to rewrite it in that form, which means that the main thing we need to do is factor out the coefficient on x, right, to see the transformation. So I'm going to rewrite g of x, all right, and I'm just going to, I think the main thing I need to do is, I've got this thing squared, but I'm going to factor out, I'm just going to get this thing squared. It's 2x minus 6, but I'm going to factor out the coefficient on x, right? So when I factor that out, I'm just going to divide each of these terms by 2, and I get x minus 3, right? So that's the same thing. It's just rewritten in a different form. And then I have the minus 1. Now I could also, right, because our general form has this a, I could also write 1 times all of that. All right, so this is a. So a is equal to 1. This is our b value. B is equal to 2. This is our h value. H is equal to a positive 3, right? Because in the general form, it's a minus h, so that's fine. If this was x plus 3, then h would be a negative 3, but it's x minus 3, so h is a positive 3. And then we have k, right? It's plus k. So this is plus a negative 1, so k is equal to negative 1. All right, so we've rewritten it, and we've identified all of these parameters. And so now we're asked to describe in words the graph of g of x in terms of the transformations to h of x. All right, so what I'm going to do is going to look back up here. We have to describe it in this order because the order of the transformations matters. And so we're going to describe the horizontal stretch, then the horizontal shift, the vertical stretch, and then the vertical shift. All right, so let's do it in that order. So number 1 is the horizontal stretch or compression. So that is the b, right? That b value is going to tell you how the function is stretched or compressed. So we're going to have a horizontal, in this case it's a compression, by a factor of, I'm just going to write by, 1/2. Remember, it's 1 over b. So those inside changes are a little counterintuitive. So it's 1 over b. So it's a horizontal compression. All right, and then we're going to describe the horizontal shift by h units. So we have a horizontal shift by h units. So it's a shift to the right. It's a shift to the right by 3 units. Okay, so I'm just going to write right by 3 because right implies horizontal, left to right. All right, so and now we have to describe the vertical stretch or compression. So I'm just going to write vertical. So the vertical stretch or compression is controlled by the a value. So actually it's 1. So there is no vertical. So I'm just going to say that. I'm going to say there's no vertical stretch or compression. All right, so there's no vertical stretch or compression. And then finally, we're going to describe the vertical shift. So vertical is up or down, where k is negative 1. So we're going down by 1. Okay, down 1 unit because it's negative, so down. If it was positive, it'd be up. So, All right, so now we've described our transformations, and now we're going to sketch a graph of this thing. F of x was x squared. So let me make some room here. I'm going to draw an axis across here. And let's see, that's our x-axis, and then we need a y-axis. Put that here. Now this is just a sketch. Oops. Yeah, this is just a sketch. So I'm just going to show x squared. So let's put some values here. Let's say this is -1, this is 1, and let's say that this is 1. And okay, down here is I don't know, -1. It's not. Got to get an even scale, right? We need a linear scale. So, all right, good enough. But I know x squared goes through 0, 0. 1 squared is 1. -1 squared is 1. So we have the graph of x squared should be familiar to you. Let me just see if I can get this to look. Well, you kind of get the idea. Okay, there's the graph of x squared. So this is our f of x function right there. It keeps going. But this is x and this is y. I gotta label my axes and I gotta have a scale on it. All right, so let's put some more numbers in here because this is a compression by 1/2. It's right by 3 and no vertical stretch or compression, and down by 1. So let's put some more values over here because we have to go right by 3. So this is 2 and this is 3. We're going to go right by 3 where it's compressed, and we're going to go down by 1. So we're going to end up down here, and then these values when x was 1, right now it's compressed horizontally, right? So we're going to end up at like 3.5. Yeah, 3.5. Yes, because there's no vertical stretch compression. It's all horizontal. So we're going to end up about here and halfway here, right? So we're compressing it horizontally. We're squeezing it down. And and then of course we're down by 1. All right, so I'm just going to try and draw that. Maybe I should draw it in a different color. Let's draw it in a different color. I'm going to sketch it in. This is a very sketchy sketch. But you get the idea. All right, so we have a function that looks like this. The horizontal compression makes it narrower. It squishes it down in the horizontal direction. We went right by 3, no vertical stretch or compression, and then we went down by 1. All right, so that's that example, and I'll meet you in the next video for the last example.